Well, let's see if we can get through a few more of these review exercises. Number 16 is looking for a quotient rule here. So I've got my low part is 6x plus 1 times the derivative of the high part is 18x minus the high part times the derivative of the low part. And it's all over this low part squared. Alright, so then this is the end of the quotient rule portion. It's just a matter of distributing. So of course I'm just going to multiply those together. This goes to both. So I've got, that's 108x plus 18x minus 54x squared. It's x squared too, sorry about that. And this is all going to be over 6x plus 1 squared. Well, I can simplify these two and just get 54x squared minus 18x all over 6x plus 1 squared. So this is, we'll call this an answer. So you've done the problem correctly, you got this answer. If you're taking a test from me, you would have it right. The final, though, is a multiple choice test. And so you may notice that you could factor out an 18x from the top, which would leave you 6x, is that right? 3x here. 3x here, and then minus 1. And this all over 6x plus 1 squared. So when you solve a problem like this, it kind of has two parts. One is to figure out what the solution is by applying the appropriate derivative rule. The other part is going to be trying to sort out of the answer choices which one actually is the same as yours, but just in a differently simplified look. Next up, we have a chain rule, because I have a function inside of a function. Let me rewrite this. Here's my outside part, something to the fourth. And then my inside part is 4x to the fourth minus 4x squared plus 1. So to find h prime of x, the idea is that I do the outer derivative first, this red derivative. So this would be 4 times this inside part cubed. And then I would multiply by the derivative of the inside. So that's going to be 16x cubed minus 8x. And the plus 1 has a derivative of 0. And then the only other piece is this inside part here. In this space, you actually just leave the exact same expression you had there before. So this would still be 4x to the fourth minus 4x squared plus 1. That part, it doesn't change at all. And then we've just got the task of sort of reorganizing this whole thing. You could write it as 4 times 16x cubed minus 8x, and then that whole thing times 4x to the fourth minus 4x squared plus 1 cubed. You can simplify this more. You can kind of go either way. You can distribute the 4 in, or you could actually take a 4x out, or an 8x out. Let's do that. So if I pull an 8x, I would have 32x on the outside, and that leaves me with 2x squared minus 1 in there, and then 4x to the fourth minus 4x squared plus 1 cubed. So again, you know, once you have your solution, it's going to be a matter of going back in and figuring out which of the answer choices matches with the solution that you got. Next up, the problem says you got a perimeter of a rectangle is 1,000 feet, and you're supposed to figure out the width. Well, perimeter is 2 times the length plus 2 times the width. You remember hopefully from geometry. and you also have area is length times width. Well, in this case, our perimeter is 1,000. And we ultimately want to solve for the width of this thing. And so I'm actually going to solve for L in terms of W in here. If I subtract 2W from both sides, I could actually get that negative W plus 500 is equal to L. And then I would take this value here and plug it in there for L. And now my new area expression would be that the area is, I'll write this as 500 minus W times W still. So there's my L, 500 minus W. My area expression now is 500 W minus W squared if I distribute that. So this is an expression that tells me my area based on, whatever value of W I want. Well, one of the main applications of derivatives is to find a maximum value. So it's like a main theme of calculus to know that when the derivative of something is 0, the function is either a maximum or a minimum value. So what I want to do here is actually find A prime, the derivative of this. Well, the derivative of 500W is just 500, and the derivative of W squared is 2W. I'm interested in one specific point, the point where this derivative is equal to 0. So I set this whole thing equal to 0 and solve it, and I would get that W is negative 500 divided by negative 2. Or W is 250, remember our units, feet. So, from a calculus standpoint, that's how you do that problem. You can also just go ahead and know that if you're looking for a rectangle with the maximum area, it's a square. And so, going back to this problem, it should be pretty simple. If it's 1,000 feet, I'm trying to make it into a square. It's going to be 250 on each side, so the four sides add up to 1,000.